nice what you can call it there, when we can say that it's Boolean, 0 and 1. And then let's say that I repeat the experiment 1,000 times, and I ask what is the expected, and I earn $5 every time, $5 each time A is hit. And I repeated it 1,000 times, and I'm asking what is the expected value of my earning. What is the expected value of my earning? Where, what are you doing right here? You're saying, well, if your probability is 50-50, then what your expected earning is 50% out of the $5 that you're going to get. A bit more formal would mean you are going to repeat it 1,000 times. What is my expected value of earning per trial? Per one time. One time I do this my error. And the answer would be you're earning $5 times one of my why I cannot remember why percentage sign is on this one and dollars is on the left, or the other way around. So it will be $5 times the expected value of what is X. The expected value of what is X. If I repeat it 1,000 times, then the expected value is average between the HTTP versus the emission. To be more formal, the expected value, when you look at it, even in the discrete setting, it's a sigma overall j goes from minus infinity to infinity of j times the probability that the value that I assign to X happens to be j. To make it very, very confusing. Now it's whether we can all the possible values that j might accept. That's when they are discrete, they are continuous replacing the binary integral. But when I'm looking at it a bit more closely, all of it times $5, of course. But when I'm looking at it more closely, I realize that what's the chance that if that's how I decided about X, what's the chance that I'll get as an answer for X3? Exactly 0. No matter where my error lies, it will X, my initial will not be 0. It's either 0 or 1. The same goes for j equal 5 or 17 or any value which is not 0 or 1. The only case is that X is, the probability of X is different than 0, it's just when X is either 0 or 1. So this boils down to 0 times the probability of X equals 0 plus 1 times the probability of X equals 1. That's why we like Boolean variables so much. Because, well, it could be that I miss a, and this probability is not 0, but once I multiply by 0, it doesn't really matter. So this vanish, the one, once we realize with the probability of X equals 1, we just said that if the probability to hit X is, to hit A is 50%, then in half of the cases you get your $5. So the probability is, of course, times my $5, which I'm keeping. Okay, dollar sign is from the left. Is that right? Dollar sign. Yes. Here is the second main factor probability that we are relying on or use this multiple times, but let's say it in a bit more formal. Here is another shape, B. I because it's Boolean, very same speech. Let's do a little exercise that I did with the algorithms guide. And help us clarify. Worst case, like maximum case, it doesn't work the worst. But what's the maximum value of A quad equal? Maybe it's like, I know which keys, but I'm not sure about the worst. Let's say that the order are 11, 13. And if A prime is arranged in this order, then the number of factors are big N. What will be the value counter? About 3. And for general, in the worst case, mobility. So just how do we find what flex? Forget about the mobility. If AY is monotonically increasing, like so, like in this case, then what happens here? I start when I equal 1. I equal 1, I just define x1. Is x1 on or it's definitely 11 is larger than minus infinity, so x1 will be 1. Moving to the 13, x2 will be 1 because the end of the again, and x3 equals 1 as well. At least I'm going to just to make sure that everybody understands what all these flags variables are. I'm talking random variables when I say I'm picking a random permutation. At the moment, here is a prime. I don't change the order. What is this? Can you understand what are the x's? From x1, x2, if at the last step I change a, then xn, the last element, will be 1. Otherwise, 0. So no matter what the order, counter is just sigma of the xi. Counter, how many times did I plate m? Well, for every time that I plated it, xi, the corresponding xi, gets value with 1, and the xi equals 0 does not count. Everybody is good with this number? And now I want to ask what is the probability that x1 equals 1. In this case, I do take the random permutation, some randomness, and x1 equals 1. The answer is x1. The very first number. It's not. It's the random permutation, but x1 is still defined for the first element.
Yeah, that one
is m. x1 definitely equals 1, no matter what. I don't take it. So it's what? There's no review 100% allocated. Probability of x2 equals 1 is basically the second step. If you know it, if you know well, this exercise, like let's say other one step. What is this order? Without conditional, without any conditional probability, without integrals, without, like I don't need to sum up the set of with respect to where One second. One second. The interrotation is equally right. The interrotation is equally right. In particular, A prime, so there was gradient that contains 11 and 13 and 17. I don't know who is the person doing second, but I do know that in the kind of observer barrier, the chance that this may appear in this order is just out of symmetry. It's something like a result of the order. In the reverse order. Pure symmetry. There is nothing special in 13 that makes it more likely to appear on the last one. It is just as likely to appear in the first. So between these two elements happens to be 11 and 13. If it happens to be 11 and 13, the chance that they appear in this order is the chance that they appear in the reverse order. The same goes if whichever are the two first elements in this in a. So this is one of them. It's the same argument in the linear program. There is nothing special about the two, out of all the half pairs. There is nothing special that makes these two appear on the other. Here I'm just reinforcing this rotation and we are diving into the detail. Probabilities of x3 equal 1. Essentially then in A prime, let's say that A prime contains 3 elements, and we have 3 elements. 2 small ones that are not the maximum out of the 3, and one particularly larger one that is the maximum out of the 3. The red one indicates the largest in there. What's the chance that it will be at the end of the x3? Exactly the same chance that this guy will be at the last one, or this guy will be at the last one. These are the summation of the level. This is x3. For x3 it will be 1 over 3, because there are 3 elements. One of them is the largest one. So that one of them is the maximum in 3. What's the chance that it appears at the other third one? Exactly the same chance that it appears 1 element before, 1 element before. So it is 1 over 3. And so on. So maybe that x4 equal 1 will be 1 over 4. So the probability that xn equal 1 is 1 over 4. Great. So, what is the expected number involved? Expected number of times the m is updated. You agree that this is just not yet, I'm not done with the sentence. It's not exactly the counter. The counter holds the number of times it was updated. updated in one particular experiment, one particular file. And now I must look what is the expected value of counter. Repeat this experiment million times. Each time pick a different random permutation without changing the number of, without changing the keys in A, but do pick a random permutation each time. Just repeat it million times. Ask how many times n was updated in each one, divided by how many experiments did you do. That's what I want to know. What is this value? But what did we say? This is nothing but the expected value of x1 plus x2 plus x3 plus xn. Because what we said, counter is just the sum of the flags that are weighted up. The number that are weighted. Weighs a flag every time that n is updated, which is now happily using the fact that expected or sum equals sum of expectation. And it's normally tricky. It looks absolutely wrong to me the first time that I checked it, because this fact that expected or sum equals to sum of expectation is true even if one prevents the other one, or one forces the other one, or they are completely independent. It's for a long reason. So, okay, this expression is replaced by the expected value of x1 plus the expected value of x2 plus the expected value of xn. It completely ignored that they come from the same experiment, different experiments, completely irrelevant. Now I remember that E of x1 is just the probability that x1 is 1. Plus probability that x2 is 1, plus probability that xn is equal to 1. So the expected number of times that I'm updating the maximum is log n, ln n. Because 1 plus half plus 1 over 3 plus 1 over n is more or less like computing the integral from 0 up to a of 1 over x dx. If you like it, if it helps you, I ignore this part. It's just to say that you look at the sum of all these numbers and now you can hit all of them more or less by this function. And this is just ln n plus a big note, something small that you can do. Not exactly the number of times that you are doing. Questions? Some attention with the attention to it. back to our probability of what happens if I keep a segment at random. But let's remind ourselves what happened in the BSP tree. How do I build the BSP? So I want to split all the segments in the plane, or all the triangle in 3D, into sets, so that, and put them nicely in between, such that in the tree itself I will have a line, L, and usually this line L in an auto partitioning will be one of the segments. It will be one segment SI, and the segment SI, from here to here, and the line that we call L of SI is extension of SI. The extension of SI. What does it do for us? It tells us that some segments, like S3 over here, and S5 over here, are completely on the left side of this line, L of SI, and being on the left side, they will go to the left side. So S3 will be on the left side of the line or the plane. The segment S30 is completely on the right side, so it will be stored on the right subplane. So S30 will be somewhere here. SI itself, by the way, SI itself, I don't need to push neither to the left or to the right. I let it heavily sit in the root itself, because it's used as a partition. So I don't need it. It's neither on the left nor on the right. But the violent nature of SI, or the extension of SI, is that it can pick another segment, S17 over here, that cuts SI, and the segment is not protected. So material that nothing protects it from the violent part of the ray when hitting it. We'll see in a moment how we are shielding this segment, but at the moment it's not shielded. So S17 will be partitioned at a single intersection point, becoming S17 right side and S17 left side. And in the left part of S3, I will store S17. And actually, I don't really care about this. It's only a portion of S17 at this moment. Once I approach S17 on this spiral, I will know which portion of it is relevant. When I know that if I'm going to the left side of the subtree, then everything that I see is only limited by this. So since I'm going to the left subtree, I know that everything that I'm going to see will be to the left of this line, and actually later on will be bounded by other half-planes, so like we saw. And this is not a new deal. We have the same with all the search tools that we saw. As I'm going down the tree, R tree, R tree, K tree, I always think about the region, that I know what this region of this node based on goes from the root to which, what are the elements that escorted me on the way from the root. It sounds very confusing as a syntax by itself, but we have seen exactly the same thing in quad tree, R tree, and OH tree. So I'll keep S17 on the left side, but I'll also keep S17 in the right side. Make sense? Now, S17 was just split, doesn't protect it from being split once again by SK, is the next segment that I pick will be SK. Its extension might split S17 once again. Easy to make mistakes. Splitting S17 doesn't double the number of fragments that I have. You just add one more fragment. It's not splitting and then splitting each one in half. Because taking one of the fragments and splitting this fragment. But I use a whole fragment all the time. Okay, so it was 3 a.m. Monday, and I was too tired to do anything else, so I played with the animation. And you see that I pick one of the segments, S2 in this case, and S2 sends away through everybody. And sorry, S3 in this case was picked, and let's make it S2. So to start the animation, S2 and S2 shoot its extension and breaks each one of the vertical segments into two pieces, two sub-segments, the bluish and the reddish above. And each one of them was unprotected. So what can make a segment protected, a segment shielded? Well, if I would start actually not from S3, the first segment that I picked is not S3, but instead it will be S8, my first segment, and then I'll pick S3, then the way for S3 will continue. Again, the first one that I picked, the randomness was S8. The second one that I picked, again, the randomness was S2. And the way from S2 splits S6, S7, reaches S8, but does not split. Why? It is shielded by being a partition. And it also protects anybody on the right. Now, do I need to do something algorithmically to actually enforce this protection part? Once again, once you picked one of the segments as a protection, and it actually doesn't matter, so maybe I'll demonstrate it even, hopefully no bugs. Even if my way so in this case, S9 is still protected. S9 is still protected from the red because I picked S8 earlier, and S8 doesn't only shield the other segment by itself, but everything to the right for S8 is shielded from any ray coming from the left. And vice versa, a ray coming from the right will not penetrate anything that comes from the left. The segments it protects as well as the extension of the segment. Now, how do I implement this protection? Do I actually need to check whether this way is doing? Absolutely not. I'm not going to do it. What I am going to do is to store all the elements on the right as their own subtree and build a subtree for all the elements on the right, and then build a different subtree of elements on the right. That implying that if next I pick S17 to shoot away through S17, it will, since the construction of this subtree is done recursively, it doesn't know and doesn't affect anything that happens on the right of the subtree. So in general, every cut that I do in the future will end up by existing cut. Okay, so next we need to ask what is the probability that S10 will be split. And now we need to maybe make a bit more order to motivate it. What could be the complexity of the BSP trace that I'm building to do with the last cut? What would be the complexity of the BSP? I'm talking about the running time. The moment I care search tree that will only slow down my algorithm. Impossible to hold. I need it to be close to linear. If you remember the slide that I showed you two meetings ago from Stanford's robotics lab, discussing exactly how do I use binary space partition together with a lot of other things if we have a huge graphics that are way beyond what our GPU can handle standalone. So back to all this. Why are we doing this exercise about pushing through? Because I want to ask what is the expected, what is the expected number of fragments. Fragments are pieces of segments that are generated across this world. It's great if it's linear. Not always I can generate a BSP which will have a linear sum. One of you can please find three segments or in the plane. We already saw that these triangles that we created with markers whenever we have this case that we don't have in order between segments. And on the other hand, if I have a BSP with no splittings at all, I always have a painter algorithm input frame. Right? I can always use the painter algorithm by saying our first row is a painter algorithm. If this is a line that splits my row into the left subplane, the right subplane, and my zero is right here, I first render everybody far away from the zero, then I render everybody far closer to the zero. How do I render these two? And these two recursive. If there is a BSP that doesn't cross any segments, then I don't have any issues whether each one converges by itself. It's guaranteed that you can have topological order between the two heights. Remember, topological order also means that there are two big numbers you don't know. None of them. This doesn't include this, no the other way around. But and we saw that I cannot create any BSP for this set of three triangles object in 3D because there is no order between them. There is cycle. Each one of them occurs some other part. So obviously if I try to split them by a plane such that some of them are far away and some are close to me, and none is split by this plane, there is no way to generate it. If there was, then you can use also the painter algorithm to great example. Why if there is such a plane, then why should I know such a plane? Then you cannot use the painter algorithm. But now I'm asking you a tiny little part. Row for these three segments in the plane such that we cannot construct BSP for them without split. One. Such that I cannot build a binary space partition for them. Because I can build a binary space partition, but then I have to split at least one of them. And the question doesn't necessarily refer to auto partition. You can pick any, well, planing 2D, making it a line, you can pick any line that you want. It doesn't have to go through one of the segments. So, can you come up with such an example? Can you render it? Only 3 segments, too hard. But it's still a cute puzzle. So just as the wall, if I will change it by, if I will change it free to be just a set of 2 segments, then we can definitely build the BSP for it. No matter how I arrange the 2 segments, even if I don't, I'm not a big keen on auto-partition. Auto-partition use only the segments as a direction. But you can build BSP even if they are not auto-partition. But for 2 segments, I can always build my BSP. I always find a line that splits it. You can give you tons of segments and ask you to build the BSP. Your first attempt will be pick a line that's they want no splitting. Pick a line for which some of the segments to the left, some of the segments to the right, and none is getting cut by this line. But something is changing when I'm asking for 3 segments. People, do you agree? Right. Try to split it. I can attempt to use this line. If I put it up on the partition, so then it's this guy. Symmetrically this guy. Actually, any direction that tries to split this one or this one is doomed to split this one. So splittings are necessary. You just hope that it doesn't happen too frequently. Everybody's cool with this? Okay, great. We need to have some splitting, implying that one of the segments will appear both on the left side and on the right side. We want to ask how many splittings happen, how many fragments. And in the slide that I'll go through in a second, I'll say xij equals 1 if the way of extension xij, one more flag, one more variable. Say, I'm building the BSP. I pick a segment. It doesn't matter here in the definition how I pick the segment. By the order they appear in the file. By reverse order, x, y, whichever. Some order is given. I insert a segment once at a time. I use every segment that I picked. Every segment that I picked creates a shield that prevents other segments crossing anything from the right side. And I'm asking what is the probability. And I say one of xij is one if the ray, when I pick si, create its si, creates its extension, it will cut sj. Now, possibly it doesn't cut it because sj is completely out of the way. And then, as I say, it's always 0 no matter what. The extension of si doesn't need any shielding, it just wouldn't get to hit sj. So I'm only asking for segments that has a chance to be cut. And let's repeat the same experiment that we had at the end of last class. So one of our segments is the first one to be picked. What is the probability that extension of S1, let's say that S1 will be picked at some point. S1 will not necessarily be picked as the first one. But if it is picked as the first one, if S1 is picked as the first segment, just to play, just to see that everybody understands my notation. If this is my experiment, then x of 1, comma 6 equals 1. The extension of S1 causes S of 6 to be split. Similarly, x of 1, comma 7 equals 1 over x of 1, comma 10 equals 1. 1 causes 6, 7, 8, 9, 10. All the vertical segments to be split. But now I'm saying that in this example, if I pick, had I picked as my first segment S2, had I picked as my first segment S2, does it affect in any way the probability that L of S1 splits S6? The fact that I picked S2 as the first guy doesn't increase or decrease the chances that S6 or S7 or 8 will be split, because when I pick it, it will still cut all the same. What can save S10 from being split by vicious S1? S1, as I said, will pick the first one, but had I picked just before I picked S10, if I picked S8, then my ray will not get to S10. Again, if I first pick S8, and only then I pick S1, then S10 will not be split. S8 shields protect. So now, what is the total number of fragments that I pick? Before total number of fragments is just in this our new terminology is the sigma of all the ij or xij. This is the number of fragments, and this is also the number of nodes in the BSP that we are creating. That's why we are looking at this number. What is sigma of xij, all the ij, all pairs ij. So, what I want to know in particular setting, when the order is fixed, then all the xij are fixed and I don't have any control over it. Then I know what will be the trick. I only have control about the order. And I pick a random order of the year. So if I pick a random order, in this one, what's the chance of S6 to be split by S1? The only thing that can protect S6 is in this one. What is the only thing that can protect S6 from being picked? Oh, only its own. Completely individual, completely exposed to nature. The only thing that can protect S6 from not being split by S1 is that S6 is being picked before S1. Now, each one might appear in different location in the permutation, I don't care. But I just ask is between these two elements, S1 and S6. S1 will pick first, then X16 is following, then X16 is 1, and if S6 was picked first, then X16 equals 0. So just between these two elements, which one appeared first in the permutation? Nothing special that biases you toward one or the other, or permutations are equally likely, no matter what you like so much. So between S6 and S1, the chance that S6 will not be split is half, just between these two. Keeping still S1 as the aggressor segment, what's the chance of S7 to be split? There's no chance to be split. Why? Because I didn't write it, but we have the image over here. The probability of error of S1 cuts S6 is half. So to be less than half because of our other segment, it might be most half. It can be shaped by various other ways. But what's the probability that S7 will be split? S7 is a probability. Again by S1 is like S7 can be picked in two ways. It can be picked either among the three elements, S7, S6, and S1. Among these three, S7 is the first one to be picked, it is safe. The range does not, S1 will be excluding, but if S7 is the first one to be split, then the ray from S1 does not split S7. If S6 is the first to be picked, then the ray from S1 also doesn't pick S7. The only case that S7 will be split is out of these three, the three segments, S1, the three segments, S1, should select S6 and S7. If out of these three, S1 was the first one to be picked, only then S7 will be split. Okay, so now, and so on. The chance that S7 will be split is just like the maximum exercise we saw earlier. What's the chance that out of the three, the special one will appear as the first one, 1 over 3 because there are 3 elements in the game, and one of them is special. Then S1 was the first element out of the 3 elements, S1, S6, S7. Similarly, the probability that S8 will be split by the same way is, it will happen only if, again, out of the 4 segments, which one? S1, which should away, S6, S7, and S8. No 3 of them can shield S8. Out of these 4 segments, S1 was the first one to be picked. So the probability derived from the small but 3 segments involved in S7, 4 segments involved in S8. So the combination of S8 is cut by S8, right? Because we have 4 segments with S1, or the first one is a permutation out of these 4, ignoring other segments. 1 over 4, and so on. The probability that S1 cuts Sj would be, now let's look at it. Let's have a definition of the segment of the distance from Si, distance from Si to Sj. I want to define the distance from Si to Sj. And this definition of the distance has nothing to do with how geometrically they are close or far from each other. The distance it's not a symmetric definition. Distance from I to J has nothing to do with distance from J to I. Distance from I to J is, look at the Si, the first line. Si, shoot away to it. Here is Sj. And let's assume that there are K segments on the way from Si to Sj. Not including Si, not including Sj. This way, the way that I shoot from Si will stab K other segments, some number K, 0, 1, 2, 3, 4, on its way to Si. That's the distance from Si to Sj. So the distance is K if there are K segments on my way to Si. Okay, let's make the key lemma that now should be obvious to everybody. Lemma, the probability that X is what? Explicitly the L of Si splits Sj is at is 1 over 2 plus distance from Si to Sj. Why does 2 come up? Let's think about the whole set. How many segments do you see? You see K segments that have potential to shift. You see Sj that hopefully can protect itself. And you see Si that way, so that if it is the first one that was picked out of the whole set of 2 plus K, 2 plus is K, 2 plus the distance from Si to Sj, only if this one is the first one that was picked, then L of Si will split Sj. Then we are done. Is clear to everybody? If we add S of Si will split Sj only if it is the first segment out of the many, many others. But among this subset of segments, this is the first one to be picked out of the set of segments that you see on the left. By the way, you've all seen this argument hidden inside other algorithms. Which one? Quicksort. Whatever you are asking, am I comparing one element to the other? Well, depending if I keep one element in the middle as a keyword, very similar, but everything else is the same. The only way that two elements will not be compared to each other is if some element that is larger than this and smaller than this will be picked as a keyword, which will send those elements that are smaller than one side of the rotation of quicksort and everybody else to the other side of the rotation. So it's all interesting. Anyhow, from now on, expect E of the number of segments, that's cool from this point, because now all I'm going to do is pick S1 for a moment, and now every other segment have a number which is unique, 1, 2, 3, 4, 5, depending on the distance, depending on at which order these segments are split by this way. And all here, yes, there is 1 is also in the other way, but it's almost multiplied by 1. So now, when I keep I fixed, and I look at this number, what is this number turned out to be? Still at the sigma of I goes from 1 to n. That's for the SI, that's for the aggressor, the one that I should write as the SI. But now I am having the sum of the J. What's the chance that Sj will be split by the aggressor SI? What happens when I keep SI fixed and look at the other segments when ignoring the rate from the other side? One of them has distance of exactly 0, nobody in between. One has distance of 1, one has distance 2, 3, 4, all the way up to n. So this is just sigma of J goes from 1 to n of 1 over 2 plus J. Of course, some segments are not of the game. In a sense, this is the worst case analysis that can happen. Yeah.
Wouldn't that be J equals 0?
Yeah, the rate is the segment that is impacted. Well, in the case of S6, good call. S6, there is nobody in it. So it's 2 over J, which is just plan n, what again? Summing up plan n times sigma of I goes from 1 to n of plan n, which is n. Nobody now knows really definitely much better than n squared. Think about n squared as 1 gigabyte of segments. 1 gigabyte square will be deadly, 1 gigabyte times lambda, or 1 gigabyte, hopefully, few times a week. Okay, and in return, you're getting a very fast algorithm, because the next thing which one's fast. Okay, I think that we'll summarize the BSP. What we'll start next week is to talk about more modern data structure and approximation, where the computational geometry last years made a really, really big difference about time nearestly, approximately times kind of approximately going in higher dimension. We talked about everything that is scarce of dimensionality. Things turns to be dimension goes, things turns to look like from n of the Born diagram to the rows, etc. The fourth example that we be careful for having order n complexity in the plane either it's for approximate US, maybe approximate for an oil diagram, then it's very practical to be closer. So 30-40 you can definitely run it, but considered excellent, so in which case N to ZD would be absolute derivative. Okay, thanks everybody.